All right, hopefully you guys figured out a pattern, figured out a way to find the units digit. If you didn't, stop the video here, work with other table partners, other groups, and set etc. and see how they did it. How did they come up with it? Because that's going to help you with this next part. So now I want to talk about the cycle of I. So I being the imaginary number. Well, let's start with what we know. I to the 0 power. What does that equal? Well, anything to the 0 power equals 1. Hopefully you just said that out loud. That's pretty cool. I to the 0 power will equal 1. What's I to the first power? Well, anything to the first power always equals itself. That's pretty self-explanatory. What is I squared? Well, Euler already gave us the definition for I squared. I squared is -1. Remember, if I square root both sides, I get I is equal to the square root of -1. So I squared, we already know by definition, is -1. Well, let's look at I cubed. What the heck is that going to be? What is I cubed? Well, take a look. I can use, what's this property right here? I squared times I. That is I cubed. What property allows us to multiply these together and get I cubed? If you remember the vocab word, knowing the vocab word is pretty nice, but at least if you understand why that's the most important. But the vocab word that goes is this is the product rule. Remember, when the bases are the same, it doesn't matter if it's imaginary number I or X or 2 or 17 or pi, whatever that is. When the bases are the same, we add the exponents. 2 plus 1 is 3. So I squared times I is the same thing as I cubed. But we already know what I squared equals. I squared equals -1. So I'm going to substitute I squared with -1. And what's -1 times I? -1 times anything is the negative of that thing. So it's -I. So I can look here and say I cubed is the same thing as -I. All right. So what's I to the 4th? If I try I to the 4th, I know that's I squared times I squared, because I can add the exponents. 2 plus 2 is 4. And we already know that I squared is -1, so that's -1 times -1. And a negative times a negative is a positive, so I to the 4th is 1. And I highlighted this one in red because this one, for me, is pretty key and important on remembering that particular positive one, because positive one's nice and easy to deal with. It's the magic number. 1 times anything's itself. Now there's multiple ways. I to the 5. Get a chance here, pause the video just on a piece of paper, write down and figure out what I to the 5th power is. No, actually really do it on a piece of paper. Pause it and do I to the 5th. If you've done it, there's multiple ways. Here's the way I did it, and this is why I like the I to the 4th being important. I to the 5th is the same thing as saying I to the 4th times I, because 4 plus 1, the product rule says I can add the exponents. 4 plus 1 is 5, so that is the same thing. I to the 4th is 1, and 1 times anything is just itself. So in this case, I to the 5th is I. You could have done it a different way. You could have said I squared times I cubed, and in that case you'd have had -1 times -I, and a negative times a negative is a positive, and 1 times I is I, so it still would have worked. Any way you'd like. I prefer doing I to the 4th because it's just a positive number and it's easy. You don't have to worry about negatives messing you up so much. Okay, I to the 6th. Try that one out on your own. Hit the pause, try it out. All right, so hopefully this is the way I did it. I called it I to the 4th. Bases are the same. I add the exponents. 2 plus 4 is 6, so I know that's true. I to the 4th I know is 1, and I squared is -1, and -1 times 1 is a -1. So in this case, I to the 6th is -1. I want to try I to the 7th. All right, let's see. I'm going to stick with my 4s, but there's multiple ways you can do this. I can go I to the 4th times I cubed, because 4 plus 3 is 7. That's true. I know that I to the 4th is 1, and I cubed is -I, so 1 times -I is -I. So I to the 7th is -I. And notice and look here down here. It doesn't matter what the exponent of I is. Somehow it's working out to be a 1, a -1, an I, and -I. So of course, I to the 8th, and you can try it on your own and double check me, is 1. And if you notice, just like we did on the pattern numbers for find the units digit of 2 to the 57th, what kind of pattern do you see here? If you notice a pattern, we can start to use that. So what I'd like you to do is find I to the 15th on your own. Pause it here, do I to the 15th, and then come back and check. So remember, if you're just watching the video, you can get some good stuff out of it. But if you pause where I've asked you to pause and actually do what I'm asking you to do, that's like that poster I have up behind my desk. You're putting in a little bit of extra effort and some extra thought. That's letting your brain know that this is important. It's going to stick with you better come test time. So pause here and work on I to the 15th. All right, welcome back. Let's take a look. I to the 15th, here's one way to do it. I could write that as I to the 4th times I to the 4th times I to the 4th times I to the 3rd, because 4 plus 4 is 8, plus 4 is 12, plus 3 is 15. So we know, according to the product rule, that these two are the same. And I know that I to the 4th is 1 times 1 times 1, and I to the 3rd is negative I. This is why I like using I to the 4th, because these are a bunch of 1s, just makes it pretty straightforward. I don't have to worry with a bunch of positives and negatives the whole time. But 1 times anything is itself, so this 1 times 1 times 1 is 1, and 1 times negative I is negative I. So we know that I to the 15th is negative I. But you could have done this multiple ways. I could have said I to the 3rd times I to the 4th times I squared times, as long as the powers or exponents added up to 15. Here's another way. I'm going to use the product rule and the power rule. So here I know I to the 4th cubed. This is the power rule. 4 times 3 is 12, plus I to the 3rd, 12 plus 3 is 15. So this is the same thing, but it's a little easier to write because I know I to the 4th is 1. I don't have to write 1 times 1 times 1 or 4 I to the 4th times I to the 4th times I to the 4th. I just write I to the 4th and put it how many times I'm multiplying it out. That's 1, and 1 cubed we know is 1, and 1 times negative I is negative I. So of course, I to the 15th is negative I, and it doesn't matter what I give you. I can give you I to the 256. If you recognize the pattern, kind of similar to what we did for the units digit, if we recognize the pattern, you can reduce I to the 217th power, whatever, to a 1, an I, a negative 1, or a negative I, and then it repeats itself. All right, so because I did not give you any real examples of how to do the homework problems, I want you guys working together. And this is what I'd like, is use what you already know about adding, multiplying, and dividing. With exponents, exponents to exponents, the power rule, the product rule, use fractional exponents, all those rules, understand, hey, you have to have like terms. I's imaginary numbers is almost like a variable. I can go 2i plus 3i, and I can add those and get 5i. I can go 2i times 3i, and I can get 6i squared. So hopefully if you spend some time listening to that, that little bit can help you a lot on the homework. Use the answers to help you learn. So look at the question, simplify, do what you think it is, and then look at the answer. If you're right, great. If you're not, how did they get that? How do they use the power rules, the product rules, all those exponent rules, and this new imaginary number I to get the answer? Play around with those. If you can't figure it out, ask your table partner. If your table partner can't figure it out, turn around, talk to the table group behind you. Somebody can work it out and explain it to you. You can always Google. Go to Google, use the keywords adding complex numbers or multiplying complex numbers or dividing complex numbers. Here's a hint. Mathematicians don't like an imaginary number in the denominator because they don't know how to divide that by hand. Kind of the same rules as radicals. We can't have a radical in the denominator. So if you can remember how to divide or get the radical out of the denominator, use the same premise. The concept, the principle is just the same. Use that to get the I off the bottom. All right, and then use the answers to double check. Again, if you need help, Google dividing complex numbers, and that'll probably help you out. Most of all, keep a positive attitude. If it gets frustrating, take a break, find somebody who can help you. but keep a positive attitude, because that positive attitude is going to allow you to learn. It's going to allow you to think and figure some stuff out. And if you can figure it out on your own, oh, that's going to be awesome. Threw this in there just for a little humor. I thought you guys would like it. All right, so the homework is the 1.5 complex numbers. Remember, you do have a test coming up. So when you finish this video, you can go up to the substitute teacher, get the homework. The answers are in the back. It's on Canvas. You can just pull it off of Canvas and write it on a piece of paper, however you want to do that. So finish for the lesson. Good luck. Hope you have fun and have a nice weekend.